Okay, in this video, we are going to write the equation of this graph here. We're actually going to write two equations, one for sine and one for cosine. So when you're going to write an equation, it's important to find I always work with the y values first. So I look at the vertical stretch or shrink and the vertical translation. So here we can see that our maximum value is at 2 and our minimum value is at -6. So that means that that is a distance of 6, 7, 8. So these are 8 units apart from each other. So if you think about that would be the diameter of the circle, 8 units, which means that the amplitude is 4. So the distance between the middle and the max and the middle and the middle and the minimum must be 4. -6 plus 4 puts the midline here at -2. Really good problem solving skill is to always check and make sure your distance from -2 to +2, that is a distance of 4. -2 to -6, also a distance of 4. So we've done this in a few different ways to convince ourselves that the k parameter is -2 and that the amplitude, I'm not going to call it the a parameter yet, the amplitude is 4. So those are the y's. That's made me think about the vertical moves of this graph. Next, we'll think horizontal. Horizontal is always a little more difficult and tricky to think about than vertical. When we think about horizontal, the period will be the same, but the horizontal shift, the horizontal translation will depend on whether we're thinking of this as a sine graph or a cosine graph. Let me put the midline back. Shouldn't have erased it. Okay, so thinking about 5 key points, only 5, and those 5 key points, you don't want to miss anything. So we start at the middle. If we're starting in the middle, that already ding, ding, ding makes me think this is going to be a sine graph. I go to the maximum, the middle, the minimum, the middle. So this is going to be a sine graph if I think of it this way. If I think of it as a sine graph, first let's find the period. So the period is the distance from the start to the end of your 5 points. So you can see here, 1, 2, 3, 4, 5. I started at 0. I ended at 2 pi over 3. So the period is 2 pi over 3. Again, that doesn't necessarily give me the parameter, but that does help me to know, since the period of the parent function is 2 pi, this is a horizontal compression. 2 pi over 3 is smaller than 2 pi. So I know that I'm going to have a b value that is larger than 1. Okay, so it's thinking about the x values, I found the period of 2 pi over 3. Okay, to then actually find the b parameter, we have a formula for that, which is 2 pi divided by the period gives us b. You can also think to yourself that 2 pi times something gives you, or times, 2 pi times b, sorry, the period times b would give you 2 pi. There's a whole video about that. Now, when you have a number divided by a fraction, the way that you solve that is you multiply by the reciprocal of the denominator. So we have 2 pi divided by 2 pi over 3 is 2 pi times 3 over 2 pi. 2 pi over 2 pi makes 1, and we find that b is 3, which makes sense. We knew this was going to be a horizontal compression. We can see here, if the period is 2 pi over 3, we took 2 pi and we broke it up into 3 pieces, then it's going 3 times as fast. By the time I would get to 2 pi, there would be 3 of these sine waves. So it makes sense. Again, I've thought it through a few different ways. I don't just do it one time and get the answer. I've thought about it in a couple different ways. It's a compression. It's got to be larger than 1 because compression works inversely. There's going to be 3 times as fast moving around. So I know that b is going to be 3. Using sine here, we will find now the horizontal translation. I'm just going to switch colors so things don't get crazy. So here, horizontal translation is the start of the 5-point cycle. And horizontal, we're looking at the x values. So yes, this is the coordinate 0, -2. But when I'm talking about a horizontal change, I'm talking about the 0. If I was talking about the vertical change, that is why there's a k value of -2. So h is 0. So when I go to actually write the function, I am going to have, let's put it in red, y equals, now, the sine of something. So a and k affect the output. A is added or subtracted, and K is added or subtracted, and A is multiplied by the output. So A always multiplies. We'll put the A right here. You could multiply at the end, although you'd need more parentheses and things might get confusing. And then K always adds or subtracts. Oh, in this case, we're actually going to subtract 2 instead of add. You could still say we were adding. We would just be adding the value -2. So A always multiplies the output. K always adds or subtracts the output. Then we have the input. So the input is X. If we had we have a horizontal compression here, it is being multiplied by 3. So we're going to multiply X by 3. Since we have no horizontal translation, so this is, again, a multiplier. Since we have no horizontal translation, H is 0. We don't have to add or subtract anything to the input. So once again, anything that changes the X values changes the input. That's why both B and H are part of the input of the sine function. Anything that changes the Y values changes the output. That's why A and K are both part of the output of the function. When you multiply, you change the shape of the graph. When you add or subtract, you just move it up, down, left, right. Let's graph this. 4 sine 3x minus 2. So if we go to Desmos, 4 sine 3x minus 2. We can check here that it passes through the points that are on the other side, 0, 2, pi over 6, 2, pi over 2 comma -6. This point here, we have to kind of estimate -2 pi over 3. And if we go back, we can see that those are the same exact points that we saw on the sketch here. All right, now we could have written a cosine graph instead. So we are going to look at that right now. So if instead we wanted to write a cosine graph, so when we write a cosine graph, we're moving the location of the 5 points. The only thing that is changing is the horizontal changes. So when you move this, if you're thinking about cosine instead of sine, cosine starts at its maximum. So instead of starting with this point right here, I'm going to say this is the start, this black point up here. 1, 2, 3, 4, 5. That has me end over here. Now, that just because I change the location of the point, the period will not be affected at all. We could calculate the period from this method, but as you can see, I moved over the same amount of spaces. So I moved over 2 of these spaces here. I moved over 2 of these spaces here. So the period is still going to be the same, 2 pi over 3. It's just been shifted over. If you needed to know the exact value, you weren't sure, you can always subtract this point and this point. Again, period is the distance along the horizontal. So you would subtract the X values of the coordinates. So B stays the same, everything stays the same for the period. The only thing that changes then is the horizontal translation. So we are now starting our cycle at this point right here, which is pi over 6. I know that because that's halfway between 0 and pi over 3. Half of a third is a sixth. So instead of starting at 0, we start over at pi over 6. So again, the only change to the equation is this horizontal translation. So if you were to write your equation now with cosine, A and K exactly the same. There's a 4 here. There's a -2 out here. Now, the input is getting both multiplied by 3 and subtracted by -pi over 6. As we saw in our Desmos activity, you want to make sure you translate first before you change the size, or the horizontal translation doesn't work out so nicely. So you want to have these double parentheses here so that the subtraction happens before the multiplication, or the translation happens before the change in size, the compression. So now we can graph that, and we will see that we should get exactly the same thing here. Over 6 minus 2. And as you can see, these two equations give us exactly the same graph. So that's just the way you could do it, by writing a sine graph or a sine equation or a cosine equation.